This week's Fix It Friday is about errors in mechanism questions. And in fact, this question is worth 5 marks, which is 1 for the name of the mechanism and 4 for drawing it correctly. So the first mistake is hopefully obvious, but I did include it because I have seen a number of students make this same mistake. That when they see the word name, sometimes your mind just goes straight into naming organic compounds, whereas actually what we wanted here was the name of the mechanism, which is nucleophilic substitution, with ammonia acting as the nucleophile. Okay, so there are some good things about this mechanism, but there are also lots of errors, especially with the curly arrows. So in the first bit, what's nice is that we have our correct dipole drawn across the CBr bond. So every mechanism that you do should always include dipoles as well as your curly arrows, and it almost always includes a charged species in there as well. And it often includes lone pairs. So having a look at the curly arrows, well, the curly arrow is coming from the nitrogen, but it's not coming from the lone pair. So it's going to the correct place, it's going to the carbon, which is delta positive, but it does really need to, all bonds need to start in either a lone pair or in a bond. Sorry, I meant to say all arrows, not all bonds, obviously. So an arrow is a pair of electrons, which means they have to start where there is a pair of electrons. In molecules, electrons are either in lone pairs or they're in bonds. So then looking at the bond, which is supposed to be showing the CBr bond breaking, that curly arrow needs to start from the center of the CBr bond and not come from a carbon. So arrows should only come from atoms if they are in fact like negatively charged, or if like nitrogen they have a lone pair. Okay, the next part, the intermediate is drawn correctly. So the N has a positive charge. That's because it's used its lone pair to bond with the carbon, which has lost a pair of electrons. And so you can imagine that the carbon became positive and the nitrogen donated its lone pair to the carbon, which left the nitrogen positive. The other way you can think about it, if you're confused about why the nitrogen must have a positive charge, there are 4 bonds around my nitrogen, 4 electrons from bonding. Nitrogen is in group 5. If it didn't lose an electron or have 1 less electron, there would be 9 electrons around my nitrogen if it had 5 in its outer shell and 4 bonds. So that can't be true, so it is the nitrogen that has the positive charge. However, this arrow is incorrect. So we do need to lose a hydrogen. Sometimes we get into the habit of breaking bonds, just thinking, okay, I'm just going to always move the electrons towards the thing that comes off. That is going to be true for things that form negative ions easily, such as Br minus, Cl minus, OH minus if you lose the OH from an alcohol or a carboxylic acid. That is not what's happening here, because if we do that, what we're doing is we're forming H minus, so the electrons would be going on the hydrogen and forming a negative ion, and the nitrogen would then be 2+, which is obviously a with situation. So when we lose hydrogen, we always lose it as a hydrogen ion in organic chemistry, and so we need to take that arrow from the bond to the nitrogen. That's quite a common step. You'll also see it with water and haloalkanes, where you have water joins on in the place of ammonia. Oxygen has a positive charge, and again the same thing happens. We lose H+. You may also have seen quite often that because this is in the excess of ammonia that's mentioned in the question, and because the balanced equation shows 2 NH3s, it's also a very good idea to involve the second NH3 in the mechanism. So what it's doing there is the lone pair on the nitrogen is forming a bond with that hydrogen. And in fact, that is what ammonia does. It acts as a base to form that NH4+ ion that we have in our product, NH4Br. Okay, so you might be thinking, right, we're done, because the last part of a mechanism is just drawing the product, right, and who's going to get that wrong. And if you just skimmed over the structure of the project, it would look okay. But however, I, as a marker, would be pretty upset about this way that this bond has been represented here. I want to be seeing that the N is directly attached and that the hydrogens are attached to the nitrogen if I'm going to draw structural. If you think you're likely to do that, then just draw both the hydrogens out displayed. Otherwise, you could easily lose a mark for what otherwise would have been a perfectly good structure.